So after we estimate our regression equation and get the measurement to measure the goodness of the fit-out model, so the third step for our regression analysis is try to test the significance of our model. As I mentioned, the model we estimated is just for the sample. However, the main goal is to understand our population. So we want to use the information we got from our sample to see how significantly our sample model can represent our population. In order to do that, we need to do the test. In simple linear regression model, we find that the F and the t-test provide the same conclusion. In chapter 14, I mentioned the reason they are the same because although the F-test tests the quality of the whole model, however, we only have one independent variable, so it's equivalent to see we test the whole model is exactly the same to test just the slope itself. That's why we have the same conclusion. However, in the multiple regression model, the F and the t-test have different purpose. And as I mentioned in previous chapter 14, the F-test is called the global F-test. So we test the model itself. And the t-test we call the individual t-test, and which means we test each independent variable separately, trying to see who is the free rider which didn't help us to predict the dependent variable y. So since the F-test is test the whole model, we should perform F-test first. And then if we found a significant F-test, we will use the t-test to check each individual independent variable separately. The logic here is if the F-test is proved the model is non-significant, and we will have conclusion that none of our independent variable can help us to predict our y variable. However, if F-test is significant, which means we have the very good model, however, we will avoid the free rider, which means some independent variable may not help us to predict the dependent variable, and we want to use the t-test to figure out who is the free rider in our model, and we will kick it off our model. So the F-test is used to determine whether a significant relationship exists between the dependent variable and the set of all independent variables. The F-test is referred to as the test for all lower significance. So based on my experience, former students usually make mistake when they try to write down the non-hypothesis and an alternative hypothesis. So in that case, please pay attention on how did I write down the hypothesis in our F-hypothesis tests. If the F-test shows an overall significance, the t-test is used to determine whether each of the individual independent variables is significant. A separate t-test is conducted for each of the independent variables in the model. We refer to each of these t-tests as a test for individual significance. So let's look at how can we write down the F-tests. We are first looking at the general format for the F-tests. The first, you need to write down your hypothesis. So the H0 is beta 1 equal to beta 2 equal to beta p equal to 0, which means you assume all betas equal to 0 at the same time. Simultaneously, they are equal to 0. And the H alternative is one or more of the parameters is not equal to 0. So if you only write down beta 1 not equal to beta 2 not equal to beta p not equal to 0, that's not right. Because you can think about the complement event for H alternative, H non-hypothesis, you will find it includes many different cases. For instance, beta 1 not equal to 0, but the rest of the betas equal to 0, or beta 1 and beta 2 not equal to 0, the rest of the betas not equal to 0. All those situations, are one of the possible case as the complement event for the non-hypothesis. So instead of listing all the possible cases, people usually use the one sentence to describe the alternative hypothesis for H0. That is, one or more of the parameters is not equal to 0. And the second step is write down the test statistics. So we are familiar with that. We use mean square regression divided MSE, and we will have the F statistic. Also, the third step, we will write down the reject rule. So the reject rule is if the p-value is smaller and equal to alpha. The alpha is coefficient, a confidence coefficient. Usually we choose alpha equal to 0.05. Or if the F you calculate from the second step is larger than the F statistic you checked from the T table, F table, or from the Excel. If either one of these cases happened, and we will find that we will reject the H norm, and we will conclude our model is not significant. So now let's look using the Spark Club as an example to look at how can we perform our F-test for that specific business question. So the hypothesis we write down is beta 1 equal to beta 2 equal to 0. And the alternative hypothesis we write down is one or both of the parameters is not equal to 0. Make sure you will not write down your none at this. So this is not correct. So beta 1 equal to beta 2 not equal to 0. So if you write down the HA like this, I will put a big giant cross on your answer. It's not right. So the H alternative should be one or both of the parameters is not equal to 0, because what you're listing here is just one possible cases as one of the possible cases which is not belonging to the H norm, because the real complement event for the H norm is beta 1 equal to beta 0 not equal to 0. And also we have beta 1 equal to 0, but beta 2 not equal to 0, or beta 1 not equal to 0, but the beta 2 equal to 0. So obviously you need to include all three possible scenarios to make your HA. So you cannot write beta 1 equal to beta 2 not equal to 0. This is just one of these three cases. So instead of list all three, you can just write down one or both of the parameters not equal to 0. Step 2, write down your reject rule. So the alpha will pick up 0.05, and the degree of freedom, numerator is 2 and denominator is 5. Numerator's degree of freedom is decided by the number of the independent variable you have, and the degree of freedom for the denominator is decided by the MSE. And the F statistic you check from the F table, or using the Excel you check it, you got 5.79. So you will reject H norm if the p-value is more than the 0.05, or F statistic is large and equal to 5.7. Then you go back to look at your Excel output, and as I said in the simple linear regression model, you will find the F statistic from the second part of the regression output called ANOVA table. So the F test in this example is equal to F statistic equal to 6.31, and the p-value for this F test is called the significance F is equal to 0.0427. Obviously 6.32 is larger than the criterion for the F statistic, and the p-value is more than 0.05. So you will the conclusion is you will reject H norm, and the conclusion is this regression model is very significant. Since the regression model as a whole is significant, we will perform the t-test trying to see whether the size of the advertisement or the discount amount doesn't help us to predict the number of the new customers. So we will use the t-test. So I will remind you what is t-test. The t-test, first you write down the hypothesis, the H non is certain beta is equal to 0, and the H alternative is certain beta is not equal to 0. And the t statistic, you will assert the estimated beta b divided by the standard deviation for that beta b. And the reject rule is if the p-value is smaller than or equal to alpha, or the t statistic is smaller than the lower tail of the t statistic, or t statistic you calculate is larger than the criterion t statistic, and you will reject the H non. So now let's look at our Spark Club example. So we write down the reject rule, and based on that question, and we know we have total 8 observations, and 8 minus p is the number of the observation, minus 2, and minus 1, you got 5. So the degree of freedom is 5. And you can check the t-table, you will get the upper criterion is 2.57, and the lower criterion is negative 2.57. So you will reject H non if the p-value is more than 0.05, or the t statistic you calculate is more than negative 2.57 or larger than 2.57. Now you can go back to look at our Excel output, and the same area as we are working on the simple linear regression model. On the third part of our Excel output called the regression equation, and you will find one column called t-statistic and one column called p-value. So the t-statistic column is the t-statistic corresponding to each betas, and the p-value is the p-value corresponding to each betas. So now we first look at the ad size, the size of the advertisement. First we found that the t-statistic is 3.43, and which is larger than the 2.57, so we should reject H non. And the p-value 0.018 also is smaller than 0.05. Based on t-statistic and p-value, we will have the conclusion that we will reject H non. So the beta 1 is significant. So beta 1 is significantly different from 0, and we have conclusion the size of the advertisement will significantly affect the number of the new customers. However, if we look at the discount amount, what we will find is the t-statistic is equal to 0.9491, which is smaller than our criterion t-statistic 2.57, and we will not reject H non. And also for the p-value, we have 0.3861, which is larger than the 0.05. We also will conclude that we cannot reject the H non. Both t-statistic and p-value will help us to decide that the discount fee cannot significantly affect the number of the new customer, so which we can see that the discount amount in our model is the free rider in our regression model. At the end, when you write down your final model, you can just delete this independent variable, just use the size of the advertisement as your independent variable. So the last way we can use to test the significance of our partial coefficient is called the confidence interval for the partial coefficient. So in the simple linear regression model, we use the b, the estimated beta, plus minus the t-statistic, the degree of freedom is n-2 times the standard deviation for that partial coefficient, the slope. However, in the multiple regression model, we have many betas, so the only change is the t-statistic. Before we are using t-statistic, the degree of freedom is n-2. Now we are using the t-statistic with the degree of freedom n-k-1. The k is also means p is the number of independent variables. And however, I want to mention, similar as a simple linear regression model, we don't really need to do the calculation for this interval. The only thing we need to do is we need to recognize it from the Excel output. And once we got the confidence interval for the partial coefficient, we just try to see if 0 is contained or not. So if the 0 is contained in the interval, the partial coefficient is not significantly different from 0, so the corresponding variable is not significantly affected. y, and it is not useful in predicting y. If 0 is not contained in the interval, the partial coefficient is significantly different from 0, so the corresponding variable is significantly affect y and is useful in predicting y. So the reason we just look at the 0 contained or not, because if 0 contained, we think we have certain percentage of confidence to believe that beta can be 0. If the beta is 0, obviously that the corresponding independent variable will not have impact on our y with dependent variable. So let's look at our SPAR club example. We will find the confidence interval for the partial coefficient from the same old place as the place we found it in a simple linear regression model. That is coming from our third part of regression output, regression equation. The last two columns, lower 95% and upper 95%, which is the confidence interval for the partial coefficient. So the confidence interval for the partial coefficient related to the size of the advertisement is the intersection between the lower 95% upper 95% to the row at column inches. So you will find that the confidence interval for the partial coefficient related to the ad size is between 0.54235498 to 3.77147345. Obviously, 0 is not included, and we can conclude that the size of the advertisement will significantly affect our number of new customers. However, if we look at the discount amount, so the confidence interval for the partial coefficient related to the discount amount is between the negative 0.071 to the positive 0.1541. Obviously, in this interval, 0 is included, and we can conclude that the discount amount is not significantly affect our number of the new customers to this bar club. And you know what? If you go back to compare this conclusion, you will find the confidence interval for the partial coefficient is the same. We'll get the same conclusion as the hypothesis testing. All two approach get a conclusion, that is the number the size of the commercial the size of the advertisement will significantly affect the number of the new members. However, the discount amount will not significantly affect the number of the new customers. So in next week's video, we will learn how can we use the regression output from Excel to calculate the confidence and prediction interval for y dependent variable.